So, a former NASA engineer that worked with Lockheed Martin and also contracted with DARPA is coming forward as a whistleblower and talking about how there is trillions of extraterrestrial artifacts, material, and devices scattered all over the world that are not man-made. You've got to listen to this podcast. Let's check it out together. This is the Ecosystem Futures podcast. Give this a listen.
So one of the things that I ended up getting pulled into classified programs. And one of the things I wanted to look at was to see if the U.S. government actually was using these technologies. And it turned out that my conclusion was the U.S. government was not. So from there, I ended up working in a number of different companies. I had a project with DARPA for a while. And what we were trying to do is some of the things we observed that you could have longitudinal forces inside of composite conductors. Our application that we pitched to the NSF that we worked with HANA was that we could probably use these forces for propulsion. And in our case, we're not using a large capacitor disk. We are using very small nanoparticles, and then we have the charges accelerate inside the particles and then tunnel to the next particle. And then we're under phase 2 right now. Now, some of these other materials that we looked at, some of the other strange properties that they have is real similar to what HAL's doing. It's you could have some of these materials that were built similarly, and you had them set up, instead of being a long, thin antenna, you could put them into a cylinder. So all of a sudden now, for the ends of the antenna, now you have a significant amount of area. And in electromagnetics, what they do is they have something called the gauges. And in electromagnetics, what they say is there's no radiation coming out of the ends of an antenna. So in our case, we're pretty sure, because some of the experiments that we had done in some of the places I'd been, I'd actually seen what we call electroscalar radiation, which is similar to what HAL is working on. HAL is working on a type of radiation that has no fields. But in our case, we're pretty sure that what comes out of the ends of an antenna, instead of being absolutely nothing or just being potentials, if you were to have an antenna of the right length, you could actually see an electric field associated with these potentials. So at that point, instead of using an electromagnetic squid to detect these potentials, now you could probably follow this one potential using an electric field meter. And that came out of work that some of the stuff that we observed when I was working with these NGOs is near some of these craft, electronics would always shut down. And some of the measurements we had done had indicated there was an electric field associated with these types of radiation. And that's where my work has basically gone to today. We've talked to the Air Force, and we think we could probably replicate these type of effects. And some of the things that comes out of this is that we really do have some kind of radiation coming out of the ends of an antenna, which would be a longitudinal radiation. And having an electric field and an oscillating scalar potential also implies there might be another field out there that we can't measure right now. And one of the things that the Air Force has wanted us to do was to see if we could try to measure this other field. And this other field is kind of similar to what Chance is observing with some of his effects. We assume that this field will do things like put a pressure on something, or like take some other device that's measuring, say, a diffraction pattern and be able to move it a little bit. So a lot of our research is really confirming what everybody else seems to be working on here. And for the NSF, our real objective is to be able to take these new metamaterials and try to generate an external force. And internally right now, when we are able to apply a DC current to these materials and we're observing these accelerated charges in these nanocomponents, we can see pretty large forces inside these materials. We're using relatively low currents. And a lot of these materials have somewhat of a high impedance, so they do take high voltages. So this is really where a lot of our work's been going on. Oh, and then some of the things with Larry, some of the places I've been, there are organizations, these NGOs, did get a lot of that data that you were looking for. But when I looked at the data, I didn't see anything like a nitrogen. So the ones that I worked with were trying to figure out how these rather large craft, which people call triangles, would be able to disappear on a dime. So when we were set up looking at these triangles, when they decloaked and they recloaked, we didn't see anything like that. What we really saw was it appeared to be that these triangles were taking whatever was, an example would be whatever was behind them and actually projecting it in front of them, which might be equivalent to taking the light rays and bending it around the actual triangle. And so our conclusion, they were doing something along those lines. They were probably doing it with a lot less energy. But some of the conditions we observed them on was a lot of times where they were observing behind them would be a little different than what we would be observing. So what they would do is we would assume would be projecting what's behind them in front of them, but it really wouldn't be quite what we would be seeing. And then we had an idea that we could probably track these triangles because their cloak or whatever they're using to bend the light around them was never going to be exactly the same. So some of that work that I was doing with NGOs was really exciting. But one of the other things that comes out of this is these individuals or whoever this group is that has this advanced technology probably does not want us to reverse engineer what they're working on. So they're probably using their methods or their technologies to try to keep us from doing things like reverse engineering or exploring how they work, just because of the fact that gives them an advantage over us. So a lot of my work really comes out of the work I do with NGOs, and I think we are on the cusp of actually developing new technologies, because I think we're all here on this group, we're all working all in kind of the same direction, where I think within 5 or 10 years, a couple of us, or hopefully us, will have new technologies out here that'll change the world. And I think propulsion is one of them. Like I said, I think we're really on the cusp of actually being able to develop propulsion. But one thing I did notice was looking at some of these materials is they were smart materials. Like one of the things is when these materials, you'd be looking at them and you try and reverse engineer them, that they would turn to dust. And they would do it within a minute or two. And then so you could take the dust and then send it off and get the isotopic analysis done on them. And they were extraterrestrial. But these materials, we're looking at something that's hundreds of years ahead of us. When you look under a microscope or an electron microscope, you're looking at something that's composed of very small particles that seem to be communicating with one another. But I think that's one of the reasons why extraterrestrial materials are not really available to most people, is because most of them are set to disintegrate if they get in the wrong hands. The isotopic analysis of the dust that's left behind tells you it's extraterrestrial, at least where it was manufactured. But so we're looking at materials that can reconfigure themselves. They are composed of small subunits. So the type of things I looked at were something as small as a sliver of metal that would reconfigure itself depending on where it was. It would cloak itself and it would try to blend into the environment. So the ones that this one NGO used to get a hold of were the ones that were technically broken. I guess the ones that didn't really function very well. So then you could collect them every once in a while and then try to analyze them. You could do things like split them apart. They would attempt to find each other or reconfigure. Some of the experiments they did was we took one of those and we put it on a very hot surface of about 3,000 degrees. And what it would do is it cooled the surface around itself. And then when we took the device off and then weighted again, we would find that the mass would be reduced by a certain amount. So these are really curious types of materials. So that's how we could kind of tell they were extraterrestrial, because these things weren't like decades ahead of us. They were probably hundreds of years ahead of us.
Yeah, we found that they were layered alloys at the micron levels, and none of our technologists, even in the big aerospace corporations, could make these layers bond together. So just by their physical construction, we could tell it was way beyond anything that had been manufactured in our ordinary technology here on Earth.
Yeah, that's what I saw too. You were looking at the outside of a craft or materials that came from a crashed spacecraft or something?
Yes.
Yeah, so we were looking at very little things. They seem to deposit all over the world. We were estimating there's probably trillions of these things that are deposited, and they have all sorts of functions, which really kind of implies that maybe this group is actually manipulating our species. But you can still acquire those. You know where to look for them. We know how to find them.
Well, if you find a hatful, why don't you send them our way and we'll take a look at them?
Yeah, that's it. So the group I used to work with, I don't talk with anymore because they got upset at me for talking. But I have an idea where someone could get them.
So that was Richard Banduric on the Ecosystemic Futures podcast. Go and listen to the full thing on Spotify. Absolutely fascinating. Let me know down in the comments below what you think. Disclosure is happening, and it's happening now.